Assalamualaikum warahmatullahi wabarakatuh. So our group gonna present about the assignment for advanced differential equation. For group members, I'm Muhammad Farhan bin Arifin, and next we have Muhammad Fidaus, and lastly we have Muhammad Hanafi. So firstly, for the introduction, what is Fourier series? Fourier series were first used by Joseph Fourier to find solution to the heat equation. A Fourier series is an expansion of a periodic function into a sum of trigonometric functions. The Fourier series is an example of a trigonometric series, but not all trigonometric series are a Fourier series. Next is a simple chart for this chapter, which is Fourier series. It can be divided into three segments, which is full range, half range, and harmonic analysis. For half range, can be divided into another two segments, which is for even function and for odd function. And for harmonic analysis, the question usually will give data and the answer will be approximate value.
Assalamualaikum, my name is Muhammad Fidaus bin Muhammad Jeffrey, and I will be presenting on task 1, which consists of 3 questions. So the first question is this one. So based on the graph plotted, we can see that the function is symmetry on the y-axis, so the function is an even function. So this is the solution for question number 1. So since fx is an even function, the value of Bn is equals to 0 for all value of n more than or equals to 1. So next is question number 2 for task 1. So for the function given, based on the graph plotted, we can see that the function is symmetry about the origin. So the function is an odd function. Since fx is an odd function, so the value of an is equals to 0 for all value of n more than or equals to 0. So for question number 3, based on the graph plotted for the function is neither even nor odd because the function is not symmetry on the y-axis or about the origin. Since fx is neither even or odd function, so we have to calculate for the value of a naught, an, and bn. So this is the solution for question number 3.
Assalamualaikum and a very good morning to Sir Shafidin and to my fellow friends. My name is Muhammad Hanafi bin Abdullah, and today I will explain about the question 2. For task 2, we have the function fx is equal to x minus 2. For x is between 0 and 2 with interval of 4. It's defined on half range. Firstly, cosine series. In cosine series, supposedly fx is an even function. So we have to find the value of AO and AN while the value OBN is equal to 0. This is the expression for the function of fx equal to x minus 2. Then we put the function into the formula of AO and AN given. Then we solve it. Thus we will get the cosine series. Secondly, sine series. When sine series, supposedly fx is an odd function. So we have to find the value of an while the value of an is equal to 0. This is the sketching for the function of fx equal to x minus 2. Then we put the function into the formula of the n given. Then we solve it. Thus we will get the sine series. Lastly is neither. When for Fourier series neither, we have to find the value of AO, AN, and BN. This is the sketching for the function of fx equal to minus x minus 2. Then we put the function into the formula for AO, AN, and BN. Then we solve it. When we solve the equation for AN and BN, we use tabular method. Then we finish the equation. Thus we will get Fourier series neither. Thank you.
For the task 3, it's about harmonic analysis. So the question given a period of 2 pi, and it also given the value of y sine x and y cos 2x. For this particular question, firstly we must construct a table which consists of x, y cos x, y sine x, y cos 2x, y sine 2x, y cos 3x, and y sine 3x. We do until y cos 3x and y sine 3x because of the question must include until third harmonic. And for the y sine x and y cos 2x given by the question, so we just put the value into some value. After we construct the table, we must calculate the initial value for A naught and C naught. So the formula for A naught is 1 over 6 multiply with sum of y from the table, and we just multiply with 1 over 6 and we get 22.867. For C naught, 1 over 2 multiply with A naught and we get 11.434. For first degree, a1, 1 over 6 multiplied with sum of y cos x, also from the table. And for b1, 1 over 6 multiplied with sum of y sin x, also from the table. And then for the first degree, we calculate for c1 and alpha 1. For c1, the formula is square root a1 squared plus b1 squared. And we just put the value of a1 and b1, and we get 2.614. And for alpha 1, tangent inverse a1 divide b1, then we get 204.143 degrees. And from the graph, you can see that it one third quadrant. And for second degree, also same with the first degree, the formula, the difference is only y cos 2x, the sum of y cos 2x. And for a1, a2, 1 over 6 multiplied with sum of y cos 2x, and b2, 1 over 6 multiplied with sum of y sin 2x. And for c2, square root a2 squared plus b2 squared. And for alpha 2, tangent inverse a squared divide with b squared. So for the alpha 2, we get 148.727 degrees, and it is in second quadrant. And for third degree, also same formula with the first degree and second degree. For a3, b3, c3, and alpha 3, just change for the a3, we just change sum of y cos 3x, and we put the value from the table. And for b3, we put the value of sum y sin 3x from the table. And from c3, we put the value of a3 and b3, we get 0.555. And for alpha 3, tangent inverse a3 divide with b3, and we get 32.717 degrees, which is in first quadrant. For the final solution, this is the formula for final solution, and we put the value into the formula, which is c0 plus c1 sine x plus alpha 1 plus c2 sine 2x plus alpha 2 plus c3 sine 3x plus alpha 3. And then we get the final solution.